video, let's talk about the Li-Fi technology and more about how it's going to work and the evolution of the technology and where it's applied, how it's applicable, and a lot of other stuff. So let's begin with the history of internet. The internet has undergone a remarkable evolution over the past few decades, transforming from a rudimentary network of connected computers to a vast interconnected web of people, devices, and data. Here are some of the key milestones in this evolution. The first version of the internet was created in the late 1960s by the US Department of Defense's Advanced Research Projects Agency, ARPA. The goal was to create a decentralized communication network that could withstand a nuclear attack. In the 1980s, a new protocol called TCP/IP was developed, which allowed computers to communicate over a standardized network. The Transmission Control Protocol, Internet Protocol, was developed by a team of computer scientists led by Wend Cerf and Bob Kahn in 1970s. Cerf and Kahn are often referred to as the fathers of the Internet for the pioneering work in developing TCP/IP, which is primary communication protocol used by devices on the Internet today. World Wide Web. In the early 1990s, World Wide Web was created by Tim Berners-Lee, a computer scientist at CERN. This made it possible for people to access information and communicate with each other through web browsers. In the late 1990s, broadband internet became widely available, which allowed for faster and more reliable internet connections. Later, in the early 2000s, as we know today, Wi-Fi technology became widely available, which allowed for wireless internet connections in homes, offices, and public spaces. Mobile internet, with the rise of smartphones in the late 2000s, the internet became more mobile accessible, allowing people to access internet from anywhere. In recent years, a new technology called Li-Fi has emerged, which uses light waves instead of radio waves to transmit data. Li-Fi is still in its early stages of development, but it has a potential to be faster and more secure than Wi-Fi. Let's talk more about how Li-Fi exactly works. So, Li-Fi stands for Light Fidelity, is a wireless communication technology that uses visible light to transmit data. It works by modulating the intensity of light emitted by an LED, which is then received by a photodiode and converted into an electrical signal. Li-Fi technology can achieve very high data transfer rates, which is up to several gigabytes per second, which is much faster than Wi-Fi. It also offers other benefits such as great energy efficiency and improved security. Wi-Fi technology has its history in the early 2000s. So let's talk about its evolution. So how exactly Wi-Fi was founded? So when Harold Haas, a professor at the University of Edinburgh, first proposed the idea of uh, using visible light for wireless communication, Haas recognized that increasing demand for wireless communication was putting a strain on the existing radio frequency technologies such as Wi-Fi and cellular networks, and he saw visible light as a potential alternative. In 2011, Haas and his team demonstrated the first Li-Fi prototype, which used a single LED bulb to transmit data at speeds of up to 10 ABS. The team showed that it was possible to use visible light as a carrier for wireless communications and achieve high data rates even in the presence of other light sources. So since then, Li-Fi has continued to evolve with researchers working to improve its performance and expand its range of applications. In 2013, researchers at the University of Oxford demonstrated Li-Fi technology with data transfer rates up to 224 Gbps, which was significant improvement from the early prototypes. Later on, in the year 2016, the Li-Fi Consortium was formed with the aim of promoting Li-Fi technology and establishing global standards. The consortium included several industry players such as Li-Fi, Signify, which was actually formerly known as Philips Lighting, and Lucibel. In the recent years, Li-Fi technology has gained increasing attention from industry players, with companies such as Signify and Curie brands investing in the development of the Li-Fi technology. Now, let's actually study how the transfer of the data happens in Li-Fi technology. So, let's first talk about modulation. So, single carrier modulation and multi-carrier modulation are two broad categories of modulation techniques that are used in various communication systems, including Li-Fi technology. So, what is a single carrier modulation? Single carrier modulation refers to a technique where data is modulated into a single carrier wave, such as amplitude modulation or phase modulation. This means that the entire bandwidth of signal is occupied by the modulated carrier wave, resulting in low spectral efficiency. However, single carrier modulation is simpler and more robust, making it suitable for applications where the data rate is not very high. On the other hand, multi-carrier modulation involves dividing the signal into multiple subcarriers and modulating the data onto each subcarrier. This can be done using techniques such as orthogonal frequency division multiplexing (OFDM). Multi-carrier modulation allows for higher data rates and better spectral efficiency, as multiple subcarriers can be used to transmit data simultaneously. However, it is also more complex and requires more sophisticated signal processing techniques to demodulate the signal. In Li-Fi technology, both single carrier and multi-carrier modulation techniques can be used, but it depends on the specific requirements of and its application. For example, single carrier modulation techniques such as amplitude modulation or on-off keying, can be used for applications where data rate is low and signal is not very complex. Multi-carrier modulation techniques such as OFDM can be used for applications where higher data rates are required and some more complex signals need to be transmitted. Overall, the choice of the modulation techniques depends on various factors such as required data rate, the available bandwidth, and the complexity of signal. The selection of the most suitable modulation technique is important for achieving efficient and reliable data transmission in the Li-Fi technology. After the modulation step, we will be talking. This is about we'll talk about the transmission. So, transmission technique in Li-Fi technology refers to the methods used to transmit the modulated light waves from transmitter to the receiver. These techniques include both line of sight and non-line of sight methods. Some of the most commonly used transmission techniques in Li-Fi are one of them is direct line of sight. This is the most straightforward method of transmission where the transmitter and receiver are in direct line of sight with each other. In this case, the light waves are transmitted directly from the transmitter to the receiver without any obstacles in between. And the second method is the reflective transmission. This method involves using reflective surfaces to redirect the light waves from the transmitter to the receiver. This technique can be used in situations where there is no direct line of sight between the transmitter and the receiver, but there are reflective surfaces which can be used to redirect these light waves. And another method is the diffuser transmission. This method involves using diffuser materials such as frosted glass or plastic to scatter the light waves in different directions. This allows light waves to reach the receiver even if there is no direct line of sight between the transmitter and the receiver. The other method is the hybrid transmission, which involves using a combination of direct line of sight, reflective, and diffusive transmission techniques to transmit the light waves This method can be used to overcome obstacles and improve the reliability of the transmission. The choice of transmission techniques depends on the specific requirements of applications such as distance between the transmitter and receiver, the presence of obstacles, and the available resources. For example, the direct line of sight transmission is the most efficient method of transmission, but it requires a clear line of sight between the transmitter and receiver. Reflective and diffusive transmission techniques can be used to overcome obstacles, but they result in a reduced signal strength and lower data rates, transfer rates. Overall, the selection of the most suitable transmission is important for achieving efficient and reliable transmission in Wi-Fi technology. And after transmission, the next step is going to be the demodulation. So what is demodulation is techniques in Wi-Fi mod technology refers to the method used to extract the information signal from the modulated light waves at the receiver end. Demodulation is an important process in any communication system as it enables the receiver to recover the original data that was transmitted. Some of the most commonly used demodulated techniques are the first one is direct detection. This is the simplest and the most commonly used techniques for demodulating Wi-Fi signals. In this method, the receiver uses a photodiode to detect the changes in the intensity of the received light waves. The photodiode converts the light signal into an electrical signal, which is then processed to recover the original data. The second method is coherent detection. This technique involves using a local oscillator to generate a reference signal that is combined with the received signal to extract the information signal. Coherent detection is more complex than direct detection, but it offers better sensitivity and more improved performance in noisy environments. And the next method is differential detection. This method involves comparing the received signal from a delayed version of itself to extract the information signal. Differential detection is less sensitive than coherent detection, but it can be used in situations where coherent detection is not feasible. The choice of demodulation techniques depends on various factors, such as signal to noise ratio, the complexity of the receiver, and the available resources. So let's talk about what SNR stands for. SNR stands for signal to noise ratio, and it is a measure of the strength of um, signal relative to the background noise in a communication channel. In communication systems, signals can become corrupted by noise, which can reduce the quality and reliability of the transmitted information. The SNR ratio is expressed in decibels and represents the ratio of the power of the signal to the power of the noise. A higher SNR ratio indicates a stronger, more reliable signal that is less likely to be affected by noise, while a low SNR ratio indicates a weaker, more vulnerable signal that is more likely to be affected by noise. SNR ratio is an important parameter in many communication systems, including wireless networks, cable networks, and digital subscriber line connections. Coming back to the topic, the direct detection is the simplest and the most commonly used method, but it has lower sensitivity than other techniques. Coherent detection offers better sensitivity, but it requires more complex receivers and a stable reference signal. Overall, the selection of the most stable demodulation techniques is important for achieving efficient and reliable data transmission in Wi-Fi technology. So next, we can, as we all know that at current time, Wi-Fi is used almost everywhere. So let's compare the Wi-Fi technology with Wi-Fi. So Wi-Fi are both wireless communication technologies, but they also differ in several aspects. And some of the key aspects of these comparisons are data transfer rates. Wi-Fi technology has the potential to achieve much higher data transfer rates than Wi-Fi with speed up to several gigabytes per second. But Wi-Fi technology typically has lower transfer data transfer rates, with the Wi-Fi 6 standards offering a maximum speed at around 10 gigabytes. Range Wi-Fi technology has a shorter range than Wi-Fi, typically limited to the area covered by the light source, whereas Wi-Fi technology has longer range, which covers typically extending up to several hundred feet. Now, talking about security, Wi-Fi technology offers greater security than Wi-Fi, as the visible light cannot penetrate through the walls of other obstacles, making it difficult for an unauthorized user to intercept the signal, whereas Wi-Fi technology is susceptible to eavesdropping and hacking, as the wide radio waves used to transmit the signal can pass through walls and other physical barriers. And talking about interference, Wi-Fi technology is less susceptible to interference from other devices, as visible light signal is less likely to be affected by other electronic devices. Wi-Fi technology can be susceptible to interface from other electronic devices, which can cause signal degradation and slower speeds. And the last point is, or last but not the least, hardware requirements. Wi-Fi technology requires specialized hardware such as um, LED bulbs with built-in modulation capabilities and photodetectors to receive the signal. Wi-Fi is more widely available and supported by a wide range of devices, making it easier to set up and use. Talking about line of sight, Wi-Fi technology requires a direct line of sight between the transmitter and the receiver, as the signal cannot penetrate through the walls or other physical barriers, whereas Wi-Fi technology can pass through walls and other obstacles, which is quite useful in environments where line of sight communication is not possible. Whereas in summary, Wi-Fi technology offers faster data transfer rates and greater security than Wi-Fi, but has a shorter range. Wi-Fi technology, on the other hand, has a longer range but is less secure and has lower data transfer rates. Both technologies have their strengths and weaknesses and can complement each other in different use cases. So it's completely up to us which technology we want to use under what circumstances. So let's talk more about how you implement this technology in real life. So the heart of the Wi-Fi technology is the bulb sub-assembly, which consists of a light-emitting diode or LED bulb that is embedded in a dielectric material. The dielectric material serves two main purposes in a Wi-Fi system. Firstly, it acts as a waveguide that helps to focus the light waves emitted by the LED bulb and direct them towards the receiver. This helps to increase the efficiency and range of the Wi-Fi system, as the focused light waves can travel over longer distances without losing their intensity. Secondly, the dielectric material serves as an electric field generator that modulates the live waves to transmit data. By varying light electric field of the dielectric material at high frequencies, the intensity of the light waves emitted by the LED bulb can be demodulated to transmit data. This modulation technique is known as amplitude modulation and is similar to the way that radio waves are modulated to transmit data in traditional wireless communication systems. So, the third one is what is RF driver. So, what is an RF driver? So, an RF driver, also known as radio frequency driver, is a software component that controls the transmission and reception of radio frequency signals in wireless communication systems. So, RF drivers are typically used in wireless networking devices such as Wi-Fi, modems, routers, and wireless adapters to enable wireless communication between the devices. The RF driver software communicates with the hardware components of the wireless devices, including the RF transceivers and antenna, to manage the transmission and reception of wireless signals. RF drivers may also include advanced features such as signal strength management, interference detection, and channel selection to help optimize the performance and reliability of the wireless network. So there is also a power amplifier. So what is a power amplifier? A power amplifier is an electronic device that converts electrical energy into radio frequency power. In a wireless communication system, the PA is a critical component that amplifies the low power signals generated by the transceiver to a high power level suitable for transmission through the air. In a LiFi system, the P assembly uses LDMOS, laterally diffused metal oxide semiconductor device. uh, LDMOS is a type of transistor that is commonly used in RF power amplifiers due to its high power efficiency and linearity. The PA assembly in a LiFi system is designed to be robust and efficient in typical and it is typically built with high quality components and also designed to withstand harsh operating conditions such as high temperature and humidity. The the RF driver in a LiFi system also contains control circuits for digital and analog lighting controls. These circuits allow the user to control the intensity and color of LED bulbs using LiFi systems as well as adjust the modulation frequency and other parameters of the system to optimize performance. Overall, the PA assembly and RF driver are critical components of the LiFi system that work together to convert the electrical energy into RF power, amplify the signal, and demodulate the light wave to transmit data efficiently and reliably. So, since we have spoken and learned about the how exactly the LiFi technology is put into place in real life, let's talk about its current applications in the at the time. So, LiFi technology is constantly evolving with new products and research findings emerging all the time. Here, some of the latest developments of the LiFi technology are the Pure LiFi. It's a Scottish company called Pure LiFi has developed a range of LiFi products, including LED bulbs and wireless access points. Their products are use a patented modulation technique called Pure Li-Fi X, which enables high-speed data transfer rates at up to 20 Gbps. So, and also the researchers are constantly exploring ways to improve the performance of Li-Fi technology. Recent research has focused on techniques such as adaptive modulation and coding, which can help to optimize the data transfer rates and reliability of Wi-Fi systems. Wi-Fi technology has the potential to be integrated with the Internet of Things (IoT), enabling a wide range of applications such as smart homes and smart cities. So, researchers are exploring ways to use Wi-Fi to provide high-speed data transfers for IoT devices, as well as using Wi-Fi for indoor positioning and other location-based services. Wi-Fi technology is also used in conjunction with the 5G networks to provide high-speed data transfer and improved connectivity. Researchers are exploring ways to integrate Wi-Fi with the 5G networks, enabling new applications such as virtual and augmented reality. And LiFi technology has the potential, the applications in underwater communication, where traditional radio-based communications is often unreliable. Researchers are exploring ways to use LiFi to enable high-speed uh, data transfer and communication in underwater environments. So there's also a Chinese smartphone manufacturer, Oppo, has patented a smartphone that supports Wi-Fi technology, which is much faster than Wi-Fi. In summary, Wi-Fi technology is continuing to develop rapidly with new products and research findings emerging all the time. Researchers are exploring ways to improve the performance, integrate Wi-Fi with other technologies, and explore new applications but it also comes with some disadvantages. So let's talk about the main disadvantage in this communication system. So it the first one is special hardware needs. So it needs specialized hardware for implementation, which isn't currently available on a large scale. And the current technology must be upgraded in order to for Li-Fi to be implemented on a large scale and for common public to use it. And since the technology is new, there has been a huge amount invested in its research and development, and hence Wi-Fi technology is very expensive. Wi-Fi has demonstrated extremely high downlink speeds, whereas there has never been any mentions regarding the uplink and also clarity on how it is being implemented. Now, the other issue is interference. Wi-Fi signals are prone to interfere from everyday lightings such as sunlight, common household lighting, etc., due to the use of the visible light for its transmission. Wi-Fi signals are susceptible to for interference from external light sources such as sunlight, fluorescent lighting, and even other Wi-Fi systems. This can result in signal degradation and affect the reliability of the data transmission. And the other disadvantage is the limited range. The range of Wi-Fi is limited due to two major factors: dispersion of light and inability of light to penetrate optically opaque objects. The other disadvantage is the widespread use of Wi-Fi is a major factor preventing the use of Wi-Fi. The limitation of Wi-Fi makes it a difficult task to replace conventional Wi-Fi networks. So these are the major disadvantages in this technology. Now it's time to look at some of the potential applications of Wi-Fi technology and where it can perform better than Wi-Fi. So some of them are high-speed data transfer rates. Wi-Fi technology, as you know, that it has got great speed, so it can be used. It is suitable for applications such as video streaming, gaming, and virtual reality. And the next one is the healthcare. Wi-Fi technology can be used in healthcare environments such as hospitals, clinics, to enable faster and more reliable data transfers for medical devices and improve the security of sensitive patient data. The next one is the transportation. Wi-Fi technology can be used in transportation settings such as airports and train stations to provide high-speed data transfers for passengers and improve the efficiency of transportation systems. The next one is the agriculture. In agriculture, Wi-Fi technology can be used as greenhouses and indoor farming facilities to provide high-speed data transfer for monitoring and controlling environmental conditions, which can improve crop yields and reduce resource usage. The next one is the defense and security. So, Wi-Fi technology can be used in defense and security applications, such as military facilities and government buildings, to provide high-speed and secure data transfer and improve the situational awareness. So, Wi-Fi technology can also be used in public spaces such as stadiums, parks, to provide high-speed data transfer rates for the visitors and improve their overall experiences. So, and it can also be implemented in places where there is difficulty to operate with the optic fibers. In conclusion, Wi-Fi technology has many potential applications and disadvantages and advantages over traditional Wi-Fi. It is still in the early stages of development and faces some significant challenges. Once the main challenge facing One of the main challenges facing Wi-Fi technology is the need for line of sight communication between devices. This means that the obstacles such as walls, furnitures can interfere with the signal, making it less reliable than Wi-Fi in some situations. Another challenge is the limited range of Wi-Fi technology, which is currently only work within hundreds of meters. So this makes it less suitable for large-scale applications. So Wi-Fi technology is a promising innovation that could offer significant benefits in certain situations only. Further research and development are done and we can expect improvement in the technology that can expand its ranges and increase its reliability. Uh, so overall, while it may not be complete replacement for Wi-Fi, Wi-Fi has the potential to be a valuable addition to the wireless communication landscape, offering high speed and secure data transfer in situations where traditional Wi-Fi may not be suitable. So this is the end of the seminar. So thank you.